Welcome to day 12 of Advent of Code 2022. Today, I've, as usual, already taken a look at the prime statement, and we are going to do some pathfinding. I have already opened the pseudocode for the algorithm we want to use. Because Dijkstra is a very well-known algorithm that I've used in, I think, previous years of Advent of Code. So I'm not going to copy paste an implementation. I like to come from the pseudocode and code that again so that I can remember this better. And as usual, we take the small input, paste it here. Okay. Today we have something a little bit different. I have updated the template that I'm using every day because yesterday I made a mistake, so I want to avoid that. So we're doing all the parsing in this function, and we are returning a new object on every function to avoid side effects between part 1 and part 2. So here we have day 12. This is correct. So what we need, we have lines. We need to map it, and for each line we split the line into an array of characters. Result, here we just display the result. Actually we can just display this console log input. As you will see, I like to run things very often to make sure it's working. Get input has already been declared. Oh, why did I have many mistakes in my template? That I've changed the template right before recording this video, and it looks like I've made a mistake. Need to fix that. Actually, let me fix that very quickly. Here, this is not get input, but this is part 2. Oops. Okay, so we have our input here. What I would like to do is to change, and I don't want to use letters, I want to use numbers. So here we are going to map. Actually, let's do const res equal an object here, and here we're going to res.map like that. Because what I want to do is I want to have an object for the start and an object for the end, so that I can store x and y, and then we have the map here. That looks good. Here we want to map, actually here we need to have the position y, and here we need to have value and the position x, so that here we can say, okay, if value is equal to s, then we do res.start is equal to yx. That's it, because y is here, x is here, so that's what we do. And we need to return, I think the start is the value a, so we're just gonna return 0, because a is gonna be 0 and z is gonna be 25. I'm always confused. Let's do that. So here we do a.char code at 0. Oop. It's 96. So we do z main.char code at 0 minus. So we have z is going to be 25. A is going to be 0. Just want to make sure this is I hate to do off by 1 errors, and this could have been an off by 1 error. So the end is e, uppercase e, so res.n. Here we do the same, yx, and we return 25. And here we can return value.char code at 0 minus a.char code at. So charcodat is something that I've used in a previous problem this year already, so that's why I know this is a way to convert a letter into a number. And basically we want A to be 0 and Z to be 25, so this is how we do. We just convert to this code that we don't really know where it starts, where it ends. We just subtract the value of A, and that gives us an array here. Oops, we do this. We have the start 0 0, the end 2 5. Let's just make sure this is correct. 2 1 2 1 2 3 4 5. That's correct. And we have things that start at 0 and that goes to 25 is the biggest. So we have our parsing that works fine. It returns a new JSON object that we can use in part 1 and part 2. We can edit it, although today I don't think we need to edit it. Anyway, now we need to actually do our algorithm, our pathfinding algorithm. Wait, before we do the pathfinding, this is the fewest steps possible. Okay, so we need the fewest step possible. So here we're just gonna implement that. Let's start. So we have, let's create that function, dig extra. I'm not sure I'm writing that correct, dig extra. So this is going to be map and start end. Okay, so here we want to go through each vertices and store distance, previous, and okay. So let's do that. So here, because I've chosen to make a two-dimensional array, we are going to need to use something that I like to create, which is function point to integer, for example, maybe point to integer. Yeah, let's do that. So here this is the point, and we return point dot y times 1 3. I think we're gonna have maps that are smaller than this big number. Let's see. Yeah. Oh, we can actually see a pattern here. Interesting. Plus point dot x, and then function int to point int, and we return y is equal to int math.floor int divided by 1 and 3, and x int modulo 1e3. So yeah, this constant is a bit arbitrary, but yeah, we know that x is always going to be below this number, so that's fine. We don't need to have another parameter. So I'm going to use that because I want to have a map to store this here for each vertex. So here we're going to say for loop, it starts with y below map.length, and here another for loop. It's going to be x, and here this is map of y. So this way we can go through each of the vertices. Here we say, let's const dist. We're just going to create an object. We could create a map, but I'm not sure if this is really useful. Previous, have this. So now what do? We do the distance to this point, dist to point to int element. No, point to int. This is actually let's put x and y here, so that we avoid passing an object. So wait, x and y. So point to int, this is going to be x and y. So here we put infinity. In JavaScript we do have infinity, so we're just going to make use of it. You know what? Let's copy paste that, because I hate like keep going back and forth between two windows. Let's make some more room. We can actually, you know what? Here we're just gonna have that on the side. Yes, that's gonna be much cooler. Hop. Okay. Let's keep that in text mode so that we don't have weird syntax colors. Okay, so we go to infinity. Then here we have previous point for this is equal to undefined. Yeah, we don't really need that, right? Because in JavaScript this would already return undefined, so we don't need that. Here we do need a queue, so const queue, and we do queue dot push. Let's call this const id is equal this, and here we use id and push id this, and then here in the end we say distance to point to int start.x start.y, this is equal to 0. Basically here we have a specific data structure and we just adapt this pseudocode to the data structure we have. So here previous, it's not initialized, that's normal. Okay, so let's do that. While q.length, so yeah, this means this is just like not empty. We can do while q.length, because when q.length is equal to 0, 0 is false in JavaScript, so that will break the loop. Okay, so here const u vertex is in queue with min distance u. Okay, so we need to go through the full array and take the one with the minimum distance to should I do a sort? No, I think I need to just go through each element. Let min equal null. So now I go for u of q if min is equal to null, or dist of u is below dist of min. Okay, so here we take the point that is the closest to the source. What do we do with that? So if min is equal to null, we need to just take the first element. We do min equal u. That's it, right? So the queue is containing IDs, and IDs is what we use. We use dist of ID to check. That should give us the right thing. So basically we should start with this value, right? Because this value is 0 and everything is infinity, so we will start with this node. Here we need to remove u from q. So how do I remove one element by value? We can just do q equal q dot filter x. X should not be equal to min. That's it. Because each element is a distinct integer. We do this, which means we remove the element. I mean, that's O of n, so that's not the best, but maybe we optimize that later if we need to. So let's continue. We are getting close to the interesting part, which is this one. So here, while q is not empty, no, wait, this part is the interesting part here. So for each neighbor, so here we need a function that is called neighbor, that gives us the neighbors. I like to create a function neighbors. Here we give x and a y, and we need to give the map as well. So const res is a list of objects. So we check actually if map of y plus 1, no, if, okay, y plus 1 is below map.length, we can do res.push, and here we do point to id to int, and this is y plus 1 and x. No, we have x and y, so it's x and y plus 1. So basically we just have to repeat that 4 times. Then here we say if x minus 1 is above or equal to 0, then we can do that. If x plus 1 is below map y.length, then you can do x plus 1 here. We basically just take the neighbors, and this is where having a matrix is making things a bit simpler. X minus 1 must be above or equal 0. And here we can do x minus 1, and this is y. That's it. Here we can return res, and this is basically giving us the neighbors, and if we are in next to the end of the map, it will handle these edge cases correctly, I believe. Something to check, but I think it looks good. It gives us a list of IDs. So here we can do that. Here const neighbors equal get neighbors. How did I call this function? Neighbors. Get neighbors. It's much better. So that we can use the neighbor variable here. So this is right now our min is okay. So here we should have stored in the variable u. So we're gonna rename a bit the things here. Here we're gonna say current, And this min variable here, we're actually gonna rename it u. I dislike one letter variables, but you know, that's fine. And here, so we're gonna say const int to point. No, const point equal int to point of u. So that here we can say get neighbors of point dot x, point dot y. Let's make sure. How did I write neighbors? Yeah, x, y, and map. The map is called map here as well. Okay, that's how to get the neighbors. Then I can go through each neighbor. For each neighbor, v of u still in queue. Ha ha ha. So we have to make sure the neighbor is in the queue. So that's gonna be a little bit annoying, because the queue, I need to, okay, let's just do that. For of neighbor of neighbors, we say if neighbor, no, if queue includes neighbor. If the queue doesn't include neighbors, we continue, we just skip. Actually, let's do the opposite. If queue includes neighbors, then we do the thing. And what do we need to do? We have a variable that's called alt. What do we need to put? We need to put the distance of u. Oh, wait. I need to remember that here, the neighbors, we need to do another check here. So we need to make sure that the neighbor is reachable. And here, in our code here, there is, no, not in the code, in the prime statement, we know you can only climb one position, one elevation, I believe. A to B, current elevation is M, you can go from 0 to N. So, and map of y plus 1 x is below map of y x plus 1 is below or equal. Yeah, that's what we want. We need to make sure that the elevation of the new position is always below or equal the current elevation plus 1. Okay, so we're going to paste that here and here, and actually we can remove minus 1 here, because here we do x plus 1 and here we do x minus 1. Do I have a mistake? Yeah, I have this that's not finished. Okay, so that should be correct for the neighbors. Now we have the neighbors that we can actually reach. So that's a good thing. That should have taken into account the full prime statement. We can come back to our Dijkstra implementation. What do we do here? We need to say distance of u plus 1, I believe, because yeah, the distance between two neighbors is always 1 in our case here. And here we say if the distance, the new distance is below dist of v. What is v? Or each neighbor v. So here actually, let's rename this neighbor from neighbor to v. We're just reusing the variables to make it easier for us. In that case, we can say dist of v is equal to alt, and prev of v is equal to u. And at the end here, at the end of Dijkstra, we can return distance and prev. However, we have missed something from this. Here we are interested in the shortest path between source and target. So we can take that. We can terminate in line 10 if u is equal to target. So let's take that. What is this? U target. Can say here if u is equal to point to int end n.x n.y, in that case we can break out of this loop and we return dist and previous with all the right information, and then we can compute the full path here. Let's try to run that. So here we const path, or actually let's just call data because I don't have any inspiration. Input.map, right? The input has map, start and end. Let's put map here. Map, we just put an empty array at first. That here it is recognized. Input dot map, yes. Then input dot start and input dot end. Here we can just output the data node day 12.ms, and we have the assignment to constant variable. That's mistake that I often do. Oh yeah, the queue here we are actually assigning it to remove one element. I think, you know what, I don't like that. Let's change that. Here we're gonna actually use splice. I think splice, but we don't know the position of. Yeah. Let's not do. Here we do let q. It should be good. What do we have here? We have start and map, and here, oh yeah, I need to output data. That's interesting. We have like a lot of numbers. So actually what we need to do this, which is getting the full path. So const path so we know let current node is equal to point to int and input dot end dot x input dot end dot y. So this is the current node, and while current node is not equal to point to int. No, actually we need to start from the end. Yeah, we start from the end. So input dot start dot x input dot start dot y. So until we have reached the end, we need to do path dot push. No, that. Yeah, we can push to the end. We push current node. And then current node is equal. We need to find the previous node from actually we don't need to get the path. We don't need to get the full path. We just need the distance. So here, let's make things a lot simpler. Const the distance, it's that. Okay. Here I'm doing something too complex. Data of dot distance to go to the point, to this point. Const distance, and here we can console log distance. Because with Dijkstra we return the path, the way to construct the path, and we return the actual distance. So I think if we do that, we have 31, and this is exactly what we wanted to have. So that's good. I think we are getting closer to the end of this part 1, because here this is 31 that we wanted. So let's take the full puzzle input, we paste that. Let's see, have we made the correct implementation of Dijkstra? That's good, that's good. Let's go to part 2. I'm gonna read that problem statement first. Okay, so here we have a small extension of the problem, which is, instead of starting from the point S, we need to check all the distances from any point A. So S is the elevation A, and all the other points A, and we need to find the shortest path from any point A to the point E. So I think, can we change Dijkstra to start from any node? I don't think so. So I think there are other algorithms where you can compute the distance from any point to any node. To be honest, I think, yeah, so actually if we start with E and we do the opposite, and we stop until we get the first A. Actually, that should be the right way to approach this. We start from E and we stop when we've reached the first A. I think that's the good way. So there are 2 ways to do this. One way is we just take what we've done so far and we loop that for, and instead of input start, we go through each point A. I think the most optimized solution isn't this one, so I would like to code the most optimized solution. So here we're gonna have to change the getNeighbor function. Yeah. So basically here, getNeighbors, let's see, getNeighbors, we're gonna pass that here. From here, we're gonna say getNeighbors. And so here I'm just gonna copy paste part 1. And we're gonna make some changes. Yes. We're gonna change the getNeighbor function. So first of all, we want to start not from the start, we want to start from the end. Actually, we're gonna need to change the full Dijkstra function. Let's do that. So here we do getNeighbors 2 and Dijkstra 2. Here we can remove that. Here we can remove that. Here we can remove that I've just added. Let's remove this Dijkstra pseudocode for now. So here Dijkstra part 2 is going to be using neighbor 2, and here we're going to be using distra 2. The start is going to be input.end, and we don't need to put an end, we just need to say let's figure out the end later. Here we have point, so basically we start at the end and we want to find the first point A. First of all, we know we need to change that. Here, when we are on a specific point, we know we can reach this point. I need to write that somewhere. Basically, the previous thing we could, when we are on A, we could only go on B, and when we were on C, we could go from A to D. Here, we have to do the opposite. We start from Z, and we know we can only get there from Y to Z. Okay, so that's thing. So we need to change a neighbor. Here we can only go to the neighbor if we are above or equal this -1. Because here, yeah, we are doing the path in reverse, so we have to reverse this condition. Up. Let's just reverse the sign for now, and we just reverse this one as well. We are in the function getNeighbors2, so that's good. And in distra2, here we need to check if we have reached the end. We need to check if map, so const current, oh yeah, here we actually have this, so we're gonna need to use that already. Point, so we need to check if map point.y point.x is equal to 0. In that case, we just stop, and we actually, here we're gonna return the right value. We're gonna return distance of u. And here we should never reach this, because we're always gonna find at least one point that has the value a. So I think if we do that, here we don't need even this thing. We're just gonna say here distance. We're gonna use the small input just to make sure we have the right thing. Here. 29, let's see. Yeah, I think that's it. Have I solved this super quickly? To be honest, if this is the correct, I will be super happy and super surprised. Let's see. So this is smaller than the first, the path from part 1. So I think this should be correct. Let's see. That's good. So I'm really happy because this is super optimized. Yeah, that's it. If you have some questions, don't hesitate to drop a comment. I'm replying to everything. Don't hesitate to drop a like. It helps make the video more visible. And yeah, if you haven't subscribed, subscribe to see the next videos. And thank you for all the new subscribers and the old one as well. That's it for today. See you in the next one. Bye bye.